All right, so it turns out there's two types of loops in Python. We've got a while loop that we saw in the last lecture, and there's also for loops. And so in this section, we're going to talk about for loops, but as a precursor, I'm going to explain a little bit about ranges, which are a really crucial concept in Python that we don't normally see in a lot of other languages. Okay, so again, before we get into for loops, let's define a term called a sequence. So a sequence is any collection of ordered things. And I say things very vaguely. It's not just characters or not just numbers, it's a sequence of anything. But so far, we've seen sequences of characters, which we called strings. Right now, what we're looking at for the first time is creating sequences, so ordered sets of numbers. And to kind of differentiate, we call those ranges. So a range can be created using a function. So a string, we have a literal representation of a string. We just have double quotes and a bunch of characters, and strings are pretty intuitive for us. Ranges are a little less common. It's something kind of more specific to Python. So the range function accepts three parameters: a start, an end, and a step. The start number, the end number, and how you're going to get there. All right, the third parameter being that step. So for example, the function range with a call with parameters 0, 10, 2 will start at 0. It'll go up to, but not including, 10, and it'll increment by 2 each time. All right, so it's a lot like that while loop that we saw iterating through all the even numbers with plus equals 2. And here we're defining a step. We can step backwards as well. So we can start at 5 and count down to 0. Again, the end is up to or down to in this case, but not including, so it's exclusive. With a step of -1 will give us 5, 4, 3, 2, and then 1. The range function is kind of flexible. You can specify all three parameters, the start, the end, and the step, but you can optionally leave out the start or the step, or both. So if you do not provide the start parameter, it's assumed to be starting at 0. If you don't provide the step, it's assumed to be 1, so incrementing to 1. So if you provide two parameters, they're interpreted as the start and the end. So down here, if I say range 1, 5, I haven't actually specified the third parameter of step. So it just starts at 1 and it goes up to, but not including 5, counting by 1. If I say range 7, that's always interpreted as just the end. So the step is defaulted to 1, and the start is default to 0. So it ought to go from 0 all the way up to 6. Okay, so what is this for? Why would you generate these sequences? Well, ranges aren't particularly useful on their own, but they can be looped through. So we define a new loop structure called a for loop. And a for loop, so we've got the keyword for, defines a variable that will take on each value within a sequence. So we've got two keywords here. We've got the for keyword and we've got the in keyword. The value I, you can call this I, you can call this J, you can call this whatever you want, will be assigned to each number that's defined in the range to the right of the in keyword. All right, and again, you can define start, you can define end, you can define step. Here I just used the default 0 through 10 exclusive. All the code associated with the for loop will be executed for each value of I inside this range of 10. All right, so in this case, and for space reasons, I didn't do it on all separate lines, but this would print 0, 1, 2, 3, 4, all the way up to 9, not including 10. Okay, so why do we use these two loops, right? So we've seen a while loop, we've seen for loops, and we can essentially do the same thing. In fact, if we look at this problem, this is something we solved with the while loop before, right? We had something like I equals 0 while I is less than 10, print I plus equals 1. So for one reason, you can kind of see that is a lot more writing than just a simple for loop, right? So the for loop is a lot more condensed, and that's one reason why we have it. It turns out you can kind of get an idea of why to use one rather than the other pretty easily. So just because there's two options and we've seen the for loop now the second time around doesn't mean the for loop always replaces what we do with the while loop. The while loop is best for loops that terminate based on a conditional. So things that involve you saying keep going while A is less than B, or keep going while the user types in an even number, or keep going while the user hasn't asked to quit, right? Keep going while some condition is true. The takeaway here is that while loops are best when you really could go around the loop any number of times. It's based on a condition that is very unpredictable. For loops are best when you know ahead of time the sequence that you're going to iterate over. Go around a loop for a specific number of times, each number in the sequence. Go around a loop n times. That's what a for loop is much more easy to write or much more effective. So we want to make sure that we choose the right loop when we go through. Throughout the rest of the course, you'll see me sometimes using while, and sometimes I'll use for loops. For loops tend to be a little bit more common, but while loops are important. And if you try to write a loop that could go around any number of times, it's based on a condition. If you try to write that as a for loop, it's going to be awkward. It's going to be difficult. If you try to write a counting loop, something that goes through a sequence, it's going to be hard to write it as a while loop. It's going to be easy to write it as a for loop. So you want to choose the right one. If you haven't seen any other programming languages, this isn't really that critical, and I don't want it to confuse you. But if you have used something like C++ before, there's something worth pointing out here about the way the for loop works and the way the range operator or the range function works. That's very important. I'm going to switch over to sketch this out for a second. In C++, and again, if you haven't seen this, don't worry too much about it. But in C++, if we had a for loop, int I equals 0, I less than x, I plus plus, right? And in C++, we'd have those brackets, right? And we had x equals 5. If we did a cout of I, which is just a print out, and then did x minus minus, hopefully you see that there's a little bit of a problem here. Right? The first time we went around this loop, we would evaluate this I less than x, right? And as we were going around the loop, x would be changing. So the first time I went around this loop, if I say what I is and what x is, x is 5, I is 0. The second time around this loop, I is 1, but x is 4. Right? And then I is 2 and x is 3, and then I is 3 and x is 2, and you'll stop. So this loop actually does not go around 5 times because we're changing the limit within the for loop. Right? So that's C++. In Python, whoops, this range operator is not evaluated every time around the loop. Right? And the while loop is reevaluated every time. The for is very different. The range function is called once. It generates, and in fact, let me keep going back here. So if I'm going to translate this over in Python. So for I in range 0, or I'm sorry, x, let's change that. When Python evaluates this for loop, it actually translates this immediately into for I in 0, 1, 2, 3, 4. And at that point, manipulating x inside the loop has no effect on this list, all right, or on that sequence that's been generated. So that's a very important point because in Python, this is going to go if I had to print I here. In Python, I will actually print 1, 2, 3, 4, and 5. right? I'll print out that full sequence. In C++ as before, when I was changing x, that would be, I'd actually go around the loop less times. So the range evaluation occurs one time. Okay. All right. So for loops, just like while loops, they take some practice getting the hang of, and the same mechanics go into designing programs with for loops as while loops. And one of the things that we saw in a previous video was that trying to print out what you're going to use, what numbers you're generating, is generally a good idea. It's often the first step towards writing a program. So I'm going to write another example. Here we're going to calculate the summation of n, of an integer, with accumulation. And accumulation, I mentioned it last time, but accumulation is just any kind of problem where you take a variable and you loop over some number of times and you incrementally add to it, or you subtract to it, or you multiply to it. But it's an answer that accumulates over the course of a loop. So I'm going to calculate the summation of n. So if n is 4, it would be 0 plus 1 plus 2 plus 3 plus 4. If it was 5, it would be the same thing, but plus 5. And I'm going to do that with a simple for loop. And we can kind of get an idea of what our sequence of numbers would be, and we probably can leave out the 0. We can generate a sequence of numbers corresponding to the value that the user types in. Right? So the first step that I'm going to do is actually print out those numbers before I do the addition. So I'm going to get n from the user. And I'll generate a for loop, I in range. And if we just do n like that. And right now I'll just print I. And I don't need to do I plus equals or anything like that. The for loop's already taken care of that for me. All right, the loop is going to automatically move through every number generated in that sequence that I've defined here. You might have heard me mention that you don't need the plus plus operator from C++ as often. That's kind of why, because the plus plus operator is generally for incrementing through a loop, but through a for loop. All right, so let's run this. Let's say the user types in 5. And so I get 0 through 4. All right, and if right away I can tell that there's something wrong here, because if I look at the slides, the summation of 5 should have been 0 plus 1 plus 2, 3, 4, and then also 5. All right, so I don't have the right sequence yet. All right, and the reason is pretty straightforward. The range, remember, if you only provide one parameter, implies that the start is 0 and if the end is n, but the end is not inclusive. All right, so this is generating 0 through or up to, but not including n. Now, what I could do is I could do n plus 1. Right? That's perfectly fine. Now, if the user types in 5, I'd get 0 through all the way through 5. Of course, adding 0 really isn't that helpful, so starting at 1 is probably a little bit more accurate. But either one would have been fine. Now that I see that the same numbers or the numbers that I want to use are coming out, now it's simply about using them instead of printing them. So again, I mentioned that this was going to be accumulation. I'm going to start with an accumulator. All right, sum. All right, sum's going to start at 0, and it's going to take on the value. It's going to increase each time around this loop. The first time around a loop, I want to add 1, and then 2, and then 3, and then 4. So instead of printing I, I'm going to do sum plus equals I. Okay. I should print out the sum. And I'm getting the right numbers. So I want to show you that I could have also done this with the while loop. It's write an equivalent program just using a while loop instead, but it's just a little bit more awkward to do. So I could have said I equals 0, or I equals 1 in fact, and I could say while I is less than or equal to n, sum plus equals I. But I'd also have to remember to do the I plus equals 1. There's another advantage over the for loop in that I don't have the opportunity to forget that, right? If I forgot that, I would get into an infinite loop. So the for loop takes away a lot of the possibility, at least, for an infinite loop. And that's a nice thing. So when you can use it, it's a good idea. But I want to prove, if I've done this right here, that the program is equivalent. There's no difference between these programs at runtime. You get the same exact answers. There's just two different ways of doing the same thing. If you can master for loops, this is a little bit more of a shorthand version to do it. There's less opportunity to mess up. But the while loops do work. And over time, we'll see some examples where for loops don't work very well, but while loops are actually far easier to work with. Okay, so let's continue. That's a more mathematical approach, or a more mathematical example. Another thing we can do is we can start printing out patterns. And again, this is all about just sort of practicing with for loops. So I'm going to rewrite a program that instead of doing some math, it's going to ask the user for a height and a width, and print out a rectangle of stars. And this is going to be similar to some of the programming examples associated with this module as well. So if the user types in a height of 3 and a width of 6, we'll see 3 rows of 6 stars. So let's move over to our code. I'll wipe this out. I'll get an input from the user. Please enter the width. And the height. And again, keep going with the way I'm solving all these problems. Before I jump into trying to print out the rectangle of stars, I'm going to print out the right number, the right numbers that I want to use. So if we look at the slides again, when I type in height of 3, I should get 3 rows. Right? So let's just make sure that happens first. I'll call it row in height. And I'll just say print row. Okay, so let's make sure that I get the right number of rows. So width really doesn't matter. I'm not paying any attention to it. Whoops, looks like I've got an error. I typed in height as 3. Int is not iterable. Yep, for range height, not just height. And again, I'm leaving out the 0. I'm leaving out the start position. If I just want to go around the loop height number of times, I'm just generating a range. This is just basically 0, 1, 2, 3, all the way up to, but not including height. All right, so the last number in this range is height minus 1. So let's try that again. Okay, so now we got 3 rows. Let's try it with a little bit different input. Now I've got 7 rows. Okay, so far so good. Now I need to print out several stars, right? So I can't get away with doing something like this, or potentially I could, right? So how do I print out with number of stars? All right, so an easy way to do this in Python is to just say star multiplied by width. All right, remember that a string multiplied by a scalar value will repeat that string that number of times. Okay, so it turns out actually it's a fairly easy problem. Okay, there's my 3 stars, 7 times. My width is 15 and I've got 9 rows. There's my 15. Okay, so that's a pretty straightforward way of handling that. If you didn't think about that multiplication of strings, another way to do this would be to print out 1 star over and over again. So I could have also done a nested loop. So for star in width, let's just call this I actually, right? So now I've got a nested for loop, and I could have printed out star. So in this case, I'm going to enter into this loop, and as soon as I enter into this loop, I'm going to enter into an inner loop that's going around 3 times, right, or whatever my width is actually. Inside that loop, I'm going to print out star with number of times, and then when I'm done with that for loop, I would go right back up to the top and print out another row. Now if I run this, this isn't going to look too good right away. So let's do width of 3, 2 rows. And you'll see that doesn't look like what I'd hope it should. I see 6 stars, right? And I see the right number of stars, but they're not separated on different rows. And that's because the print statement, when I print out a star, automatically goes to the next line. We'll see when we talk a little bit in the next module about functions and parameters. There are ways of sending more parameters into some of our functions. The print function has a default ending of the line with a new line. Right? And you can override that by saying, I don't want to print anything at the end of my print statement. And if you do that, the print statement will just print out what you want. So this end equals nothing, an empty string, will fix that little problem we had almost. All right, now I've got, of course, 6 stars straight across. Right? And that's because after I was done printing out 3 stars in a row, I went right back around the loop and I printed out another 3 stars, and I still don't have it in the line. So in that case, inside that, after that nested for loop, now I could print a new line. And in fact, I can just say print, and that'll print a new line character out to the screen. So what I've done here is I've gone around a loop and I've printed out a star with number of times without an end of line. And then once I was done with that particular row, I'm printing out a new line to go to the next row. And now I've got the right answer. This is useful for you to understand the pattern, the way I accomplish this using nested for loops. I would take some time and make sure that you understand this approach. Certainly, the easier way was the first way that I wrote it, and that's just print row times star. And if I was, doing this for real, that's certainly how I would do it. Whoops. Looks like I need to do width. So I guess what I had. Okay, and there we go. Okay, so just as to close out this section on for loops actually can iterate through or loop through any sequence. So we saw ranges as part of this module as a way to loop through a sequence of numbers, but we can also loop through a sequence of characters, and we can loop through lots of different things. Later on, when we start to cover lists, that'll become more clear. So though it's not quite as common, looping through individual characters of a string is the same exact syntax as looping through sequences of numbers. Right? So for C in a sequence of characters, which is just a string, we can assign C to be each individual value within that string. Again, if this was a while loop, we could do the same thing. C would start at 0, and we'd have to index into the string. So in this example, I'm just printing out an uppercase. And by the way, we were introducing gradually some terms or some functions. For any string, and C is just a string of size 1 in this case, you can do .upper, which will return the uppercase version of that particular string. And later on in this course, we'll see a lot more functionality associated with strings. And so here we would print out the capitalized version of each character on a separate line in this case.